Hey everybody, so this is going to be our interactive lab presentation 5, I believe. So we're going to be taking some regular old copper pennies here. I tried to find some with some good amount of grime and dirt on them. You know, not the prettiest looking pennies. So we're going to take some vinegar and some salt, mix it together in a non-metal bowl, and then mix it with a non-metal spoon. Let the salt dissolve into the vinegar, and then we're going to put the pennies in and then see what happened. So I'll add a little bit of my vinegar. It's probably a good amount. Okay, a little bit of table salt. And we're just going to stir it up. Okay, so while I'm stirring, I think it's important to talk about how pennies get to be dirty like this to begin with. So pennies, as you know, are made out of copper, right? And copper oxidizes over time with the basic elements in the atmosphere, such as like carbon dioxide and, you know, just water in the atmosphere, you know, when it's like a hot, humid day. So over time, this creates copper oxide, and that copper oxide builds on the surface of the pennies, and it creates that kind of dirty looking film almost over the top of it, because that's just, that happens, can't, you know, do anything about it. Statue of Liberty is a great example of another thing of copper that, you know, has oxidized over time. You know, it's got that green color, and you can even see on some of these pennies. Let me see if I can find one. You can kind of see the start of some green right there. So the longer pennies, or the longer copper, I should say, is left out in the open, the longer those reactions can occur with the copper and create that copper oxide. There's a good example. See, there's that green I was telling you about. Perfect. Okay. So now let's talk about why we're mixing the vinegar and the salt. So the combination of the sodium chloride and the vinegar, which contains acetic acid, right? This creates sodium acetate and hydrogen chloride. So the acetate actually will bind to the copper oxide on the top layer of the pennies, and it eats away at it. It'll erode it. And so that's kind of why it should look really clean and make a nice pretty penny after we're done dunking it. Let's see. So yeah, and the longer the penny sits in the solution, you know, the longer the reaction can occur, then the cleaner, in theory, the penny will get. So let's try just one right here, so you can see not much of a shine to it. Let's dip it in. Wait for it, and let's dip a few more in. Wow, you could almost see instantly with that one. Okay. So it might not look like it's happening super fast in real time, but I'm sure if you continually move the video feed back and forth, you'll see the reactions are happening and making these pennies shine. See, look, our first one there, I can definitely see, you can see definitely a shine on them now. So yeah, we're definitely seeing some reaction occurring here. Wow, pretty cool. So again, that acetate, that sodium acetate that's created with the salt and the vinegar, that's binding to that copper oxide, and that's removing it. And it's also removing a thin layer of the copper as the reaction is occurring, and it's causing a brand new shine to come onto our pennies. And just like the instructional video that we watched prior to this, if we take the pennies out of the solution, we rinse it under some water, all right, reaction stops. It's done. It will no longer continue to do that. But if we take one penny out, don't stop the reaction, let it sit there for a while, it'll actually start to oxidize further, and we'll see some of that green shine that we see, you know, like on the Statue of Liberty. Why? Because the sodium acetate is going to continue, when it's exposed to air, it's going to continue to oxidize it even further, actually. So it's going to do the opposite effect of when we take it out. So yeah, a really cool experiment. You know, try it out with any other old coins you find that are mainly copper. Yeah, so thank you. Can't wait till next time.